Hi, this is Dr. Bosch, and I've been getting some of the PhysioEx #2 labs in, and some people are having a little trouble determining latent period. So I thought I'd just start from the beginning on that PhysioEx lab because it is your first one of the semester. There will be many this semester, and if you go on to 202, quite a few extra lab PhysioEXs. So this is for Lab Guide 5, and it starts out with Lab 12. And when you're done with that, you go on to the PhysioEX Lab. Now this is found in the back of your lab manual. There's some blue lined pages back there. So all the instructions are back there. And so the page number is PEX 17. So it's the 17th blue lined page. That's where you find information about this. But you do have to go on, so you can just read from the book to answer these questions. Also from your lecture, we talk about latent period and wave summation. That's all in your lecture as well. So, but you can get both of the information both from your lab manual and from the lecture. It's between pages PEX 17 to PEX 23. So the blue line pages in the back. Now this is the part, I did send this to you in the weekly reminder, but here it is, and I highlighted it in yellow. A few students skipped this, and then they wondered what the heck they're doing. But yeah, you do have to do this. You have to go to Modified Mastering to get this lab. So it says log into Modified Mastering, click on your class, click Study Area on the left side, click the Launch Study Area, then PhysioEX, then Exercises, and then Exercise 2, Activity 1. And that's how it starts. So I'm just going to kind of start off with this for you to see how this works. So you sign in to your Modified Mastering, and then you have either one of these courses. It depends how you got the access card. I'll just use the textbook. Well, I'll just use the first one. This is the access from your lab manual. This is access from your textbook. I wish it was all the same, but you get to the same place. You get to this Modified Mastering course. Then almost everything we do starts in the study area here. Don't worry about any of this stuff. I don't give you assignments on here because we have Canvas. This is meant for instructors that don't have Canvas. We do. So you go to the study area, and you'd think you'd be there, but it does ask you to launch the study area. So just hit that. And then you look for PhysioEX. Here it is. Here was your lab. The pig lab was up here earlier in the semester. We're just 2 down, PhysioEX. And by the way, you should look at these practice quizzes, animations. There's lots of good stuff in this study area. But for today, we are interested in the PhysioEX labs. Let's go to that. There it says exercises. And we're looking for exercise 2. It's PhysioEX number 2. And then activity 1. So go there. And it tells you what you'll be doing. So here are your objectives. Take a look at that. And the objective I'm looking at here is to identify and measure the duration of the latent period. And I've got about 5 or 6 labs in already, and only one of them so far determined latent period. So there's a problem there. So that's why I'm doing this reminder to show you how to find latent period. So we go next. And then it gives you some of the background. So this is all stuff that's in your lecture, but might be good to read this and kind of understand this a little bit better. It's definitely worth reading. And then here's about the latent period, the time that elapses between the generation of an action potential in a muscle and the start of muscle contraction. So it's a delay for muscles to actually start to contract. And then you go from contraction phase to relaxation phase. And here's the equipment, which is all online. I did this at University of Michigan with real muscles and things like that, but it was a 6-hour lab. It was a lot to set up and do. Then you can answer these questions. Hopefully you know the answers. If you don't, it'll tell you, but you just pick the right one and check your answer if you want and go on. And then, they're called muscle fibers. And again, you can check your answer, just go on. And then a motor unit, one motor neuron, and all the skeletal muscle fibers. You can always check and see if you're correct on those. If you pick the wrong thing. Let's see, I'll just pick this one. You can check and it'll say, no, the correct answer is. So even if you mess it up, it'll quickly give you the correct answer. So it's not a hard thing to do. And then you don't really have to submit it. This is just something to do to help you do better on the lab. And then you have to read this and you have to do everything it says. If you skip anything, it won't work or you'll just have problems. So it says, note the voltage on the stimulator set to 0. Select stimulate to deliver an electrical stimulus. Now, so there's no voltage actually connected. This is a muscle of a frog sitting here. And so we can put stimulate and then you see what happens and nothing happens, right? Because we're not really stimulating if there's no voltage. The voltage is kind of simulating what a neuron would do. Remember how our muscles don't work unless there's a neuromuscular junction and we have a neuron, actually many of them, stimulating the muscle. So this acts like a nerve. And then it says to stimulate. And then you got the next button on the bottom right. Some people didn't see that. So the bottom right, then tells you what to do next. Record, it says to record the data. So hit that. And since nothing happened, there's no latent period. And then we go on, hit next again. It tells you what to do next. So increase the voltage to 3. Here's the voltage. There's a plus 1, 2, 3. Looks good. You can hit next, or the next thing it'll tell you to do is to hit the stimulate button. So select stimulate. There we go. And by the way, the graph that you're writing in your lab manual will look like this. In your lab guide, I should say, with force and then a contraction period and a relaxation period. And this is also in your textbook. It's also in the PowerPoints. So this is the kind of thing, and you do have to put in numbers and labels. You can't just leave it without that. So that's one of the things you're going to be putting in your lab guide. All right, and then, so now we actually have, so there was, 3 was enough to actually stimulate the muscle, so the muscle contracted, and we have a force of 1 right there, and these are milliseconds. That's only, 140 over 1,000 for the whole thing, so this is only about less than a fifth of a second for this whole thing to happen. So it looks long, but really realize you can have 8 of these, 10 of these during 1 second. Depends on the muscle. All right, so see what it says to do next. Select stimulate, observe the tracing. So we did that. Hit next. And it says note the muscle force that develops, like record data. So this, I think, is why it was confusing. They really should have had you measure the latent period now, because you can see when the muscle gets stimulated, it takes a little bit of time. Now we're talking about maybe 2/1000ths of a second. These are milliseconds. So very short, but it doesn't happen immediately. And that has to do with what happens when muscles are contracting. Let me see if I have this. I guess I don't. Let me see if it's that one. Yeah, there it is. This is what your essay is on for your next exam. You have to be able to say all of this. This idea that at neuromuscular junction, there's a stimulus, ACH goes across, you have an action potential going on a sarcolemma. So when you stimulate the muscle, it's as though there's a neuron on the muscle. So what will happen is that action potential, the sodium rushing in, the potassium rushing out, has to go down the sarcolemma, the cell membrane of the muscle, down the T-tubule, stimulate the SR, sarcoplasmic reticulum, to release calcium. Calcium has to be released. It'll bind to troponin, which will change shape, move the tropomyosin out of the way, which is blocking things. Then you can have a muscle contraction. Then you remove the calcium so it can go back to normal, and then the calcium gets reabsorbed into the SR again. So this is the whole thing. You don't really get a contraction till down here. That's what the latent period's about. From here all the way to here is the time it takes for this to happen. Because now we have contraction. That's step 4, right? So that's what we're looking at with latent period. So, but it doesn't say to measure latent period now, which I think you might think that there is none, but there really is one. It's right there between here and here. But anyway, it doesn't ask you to get it, so we'll wait on that. We'll hit next, select clear traces, move the tracings from the oscilloscope. So we'll get these out of the way so we can see a new one and be able to see it. We'll go to next and increase the voltage to 4 volts. So we're at 3, we'll hit 4. And you know you have to stimulate, but we'll just hit next, just select stimulate. Let's do that. So it looks about the same, a little higher because realize this muscle is made up of many fibers. So the greater the voltage, more fibers will be stimulated. And until at some point, they're all being stimulated. You can't have any more strength in that muscle. But you start with just a few, and then it goes more and more and more. And that's the same way your actual muscles work. If you're just picking up a feather, you don't have to stimulate all of your muscles, like in your biceps. But if you're picking up a block of cement, then you need them all, and so you're going to stimulate them all. So think of this as thousands of muscle fibers, thousands of cells, and you can stimulate a few or you can stimulate a lot. Okay, so select stimulate, and you're looking at the force being a little stronger. Let's hit next. Now, there's a stop and think question here, and this is very key. What's the period of time that elapsed between the generation of an action potential and the start of muscle tension development in a muscle fiber? So between here and here, see how the line goes sideways there for just a small amount? And that is called the latent period. Let's just check, make sure. Sure enough. And so now we can go to next. And this is the one that people missed. So it's number 9 here. Select measure on the stimulator. So there's measure. And then it says a thin vertical yellow line appears on the far left. To measure the length of the latent period, you measure the time between the application of the stimulus and the beginning of the first observable response. That's when the line starts to go up, an increase in force. So to find, so here's the yellow line, and you might say, how do I move that? Well, you come over here to the measure button, and oops, that went too far. Let's see. So we go down here, it's just below measure, and you can actually move that yellow line. See when I click on this, how the yellow line is moving over. Now it's kind of in the middle here. Not quite to the bottom yet though, so I'm gonna go a little farther. It's almost there. Either that one or that one. That one for sure. So at 2.80, that is the latent period. So we've measured the latent period, 2.8 milliseconds, or 2.8 over 1,000 seconds. So now, once we've got that in place, we can put record data, and now we've got a number in our data table. And then you can do the same thing for when you increase the voltage. So you can keep going from here and complete this table. So don't skip number 9, okay? Get that yellow line, go over to here, and then record it. So in this case, it'd be 2.80. So I hope that was helpful. And as you're looking at this, realize that this is zero force, and this is the contraction period, and then relaxation period. So relaxation period is a little longer, right? So this the muscle's being stimulated, it's contracting, 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 and now it's relaxing, relaxing, relaxing. When it hits here, you can do this again. Now, what you'll find in the later lab is if you hit a stimulus, say right about here, this can go higher. The reason for that is that there's still calcium in our muscles. Calcium is super important. Remember how calcium allows the myosin and actin to interact and you can have a contraction? So if you stimulate it here, it's going to go up farther with the same stimulation. Like if you left it at 4, you could maybe pull this up higher because there's calcium still there. And that's just a really important point. And that's why wave summation occurs, and it's why trepa occurs. And it's why if you play sports, you always warm up. All right, I hope that was helpful and that you can have a good time with this lab. It's kind of fun and it does work. Thank you for your attention, and I'm glad you could listen to this.